Hello students, I have come up with a very interesting question. This particular question had come in 2014 CBSE exams, and the question goes this way. If there be a set which consists of first 9 natural numbers, and R is a relation in A cross A, that is Cartesian product of two sets A and A, and the relation is as such that when two ordered pairs come together in a particular relation R, it exhibits this property, that is first plus last, that is first plus last equals to second plus third, B plus C. For A, B, C, D belonging to A cross A, prove that R is an equivalence relation. I have already told you that equivalence relation is a relation which is reflexive, symmetric, and transitive. So in this case, I need to prove that this particular relation is reflexive, symmetric, and transitive. So for reflexive, first I need to import. Okay, so if I have to import, I'll import A comma B belong to A cross A. Say A comma B belong to A cross A. A comma B, when it comes in relation with itself, what will happen? First plus last, A plus B equals to B plus A. Obviously it is true for all A comma B belonging to set A. Set A has natural number and addition is commutative. So that is why R is reflexive. I need to prove symmetric. To prove symmetric, let us import, let A comma B and C comma D belong to A cross A. Then if A comma B when comes in relation with C comma D gives me what? A plus D equals to B plus C. Let us write equation 1. What happens when C comma D comes in relation with A comma B, then what happens? First and last, C plus B, C plus B perhaps, is equal to D plus A. This is equation number 2. Here B plus C and C plus B will have the same value. A plus D and D plus A will have the same value. So 1 equals 2. So 1 equals 2. R is symmetric. R is symmetric. We have already proved R is reflexive. R is symmetric. Our work is to prove R is transitive. To prove R is transitive, I am going to write it here itself. To prove R is transitive, so I need to import again 3 ordered pairs. For transitivity, I don't know why I am writing with red. So for transitive, say A comma B, C comma D and E comma F. I have brought 3 different ordered pairs belong to A cross A and start with say, okay. When A comma B comes in relation with C comma D, we write A plus D equals to B plus C. I hope you can see this. C comma D comes in relation to E comma F. We write C comma D comes in relation with E comma F. First and last, C plus F is equals to D plus E. D plus E. Then when we add this two, I get A plus D plus C plus F equals to B plus C. B plus C plus D plus E. Now to cancel, I have a red pen. I will use that. This is C getting cancelled, D getting cancelled. So A plus F equals to B plus E. A plus F equals to B plus E means what? First and last. First and last is A and B. A comma B is related with E and F. So R is transitive. So we have proved that the given relation exhibits equivalence relation. So given relation exhibits equivalence relation. Now the last part of this particular question is, asking us obtain equivalence class of 2 comma 5. I need to tell you what is equivalence class. Equivalence class, you just remember the definition. Equivalence class, okay, so equivalence class is x moduli r is equals to all those y belonging to set A, I'm finding equivalence class of x under the equivalence relation of R is all those y belonging to A such that x is related to y. Now maybe it's difficult to understand. I'll show you like in a very simple way. 2 comma 5, when it is related with any element of x comma y, okay, from A cross A, 2 comma 5 when related with x comma y under this relation gives me what? 2 plus y equals to 5 plus x, implies 2 minus 5 is minus 3 equals to x minus y. That means I need to find x and y from these elements 1 to 9, numbers 1 to 9, so that when I subtract this 2, I get minus 3. Obviously, 2 and 5 is one such. 2 minus 5 is minus 3. So I am writing equivalence class of 2 and 5 is a set of all those numbers. If I start with 1 minus what will be minus 3? 4. I know you are saying 4 also. 2 and 5 again. 3, 6, 4 with what? 8, 5 and 9. I cannot write 6 because 10 is not given there. Sorry, 5 with 4 is with 7, sorry, and 5 is with 8, and then 6 is with 9. 6 is with 9. Fine. And 7 cannot be taken because 10 is not given there. So this is equivalence class of 2 comma 5. Equivalence class, whenever it is asked, do remember equivalence class of x under the equivalence relation R, we read it as x moduli R is set of all those y which belongs to the set A such that x is related to y. So I need equivalence of 2 when it is related to 5. So 2 minus 5 is minus 3. So I am finding all those ordered pairs whose subtraction is minus 3. Moreover, students, in my second assignment, I have given you important questions like which has come in the boards. Okay, 2015 is there, set 17 is there. So I request you all to utilize this time when you are staying back